Hello everyone, welcome back to my channel. So today we are going to discuss another problem. But before going forward, if you've not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. Problem is copy list with random pointer. Very important problem interview perspective. So let's see. A linked list of let n is given such that each node contains an additional random pointer. So we know that a linked list, right? We know a linked list has nodes and each node has data and the pointer to next node. Pointer to next node. So we have two things in a node, the data and the pointer to the next node. So in the problem what they're saying that in addition there is another pointer which is random pointer. That is our node will be storing one more value and that will be the this will be the pointer to the random like another node. So there will be a data and there will be two pointers pointer variables which will be storing pointers like address of the next node and the address of some other node, right? There will be two pointer variables which could point to any node in the list. Construct a deep copy of the list. We have to construct a deep copy. What does deep copy means? So for example, if this linked list is given, deep copy means that we have to create exact copy of this node. So 7 node is this one. Let's say in the memory this 7 node is at address, let's say 2000. So we have to create a copy of this node, meaning we'll be creating a new node with the same value as that node. So this is a copy and this is at separate address, at some address, let's say 5000. So this is a deep copy. Deep copy means it's a different node but it has the same value 7 7, but it is a different node. It's this node is different and this node is different. So this is a problem. We have to create deep copy. So this is all the explanation they have given, which is not like necessary to read. You can read it. And so we have to return the head of the copied linked list. So whatever the deep copy linked list we have created, we have to return its head. So let's see how we can approach this problem. In the question they have given us the linked list. So this is the input. Let's say this is the input. They have given this list. 7 is the node value and null is the node it is pointing to, the like null is the random node. So null is 7, random is null. 13's random pointer is pointing to 0. 0 is the index. So 0 1 2 3 4 5. So we have done indexing of this linked list. So 13 is pointing to 0 means it's pointing to the 0 index node. 0 index is this 7. So 13 is pointing, that is random pointer of 13 is pointing to 7. Similarly 11 random it's 4, right? That is here 0 1 2 3 4. So 11's random is pointing to the node which is at index 4, which is 1. So similarly 10 node is pointing, its random pointer is pointing to node which is at index 2. So 0 1 2, that is 11. So 10's random is pointing to 11. Similarly 1 is pointing to node at index 0. So 1's random is pointing to node at index 0, which is 7. Next, so obviously will be 13, then 13's next will be 11, 11's next will be 10 and 10's next will be 1. Fine. So this is the linked list which is given and this is the representation. In the function which is given in the problem, we are given the head of the linked list, which is fine, right? So head of this linked list is given. Now let's see how we'll approach it. I hope you understood the problem. This is similar to another problem which we have done earlier, which is clone graph. If you have not done that problem, after watching this problem you can try that problem also. Concept is same. So see, let's see how we can approach it. One simple way, we will be discussing two approaches, right? We will be discussing two approaches for this problem. One approach will use extra space, and the other approach will be of constant space. That is, it will not use any extra data structure. So obviously this one is more optimized because it's using constant space. So first we will discuss this one and then we will discuss this one. If you know this approach, extra space approach, you can directly jump to this approach. So let's discuss the approach in which we uh, have to use extra space. So this, like, see guys, here yellow is the next pointer, this is your next, and the blue one is the random. So 13's random is pointing to 7, 11's random is pointing to 1. Fine. So see how we will approach this problem. What we have to do is we have to create a deep copy, right? We have to create copy of every node. 7's copy, like this 13's node copy, which is 13, 11's will be copy, and 10's copy, and 1's copy, and then we have to connect them. 7's random will be connected to null, so here will be null, so it will be null. Then 13's random, this is the new node, right? This is a copied new node, copied node linked list. 13's random will be pointing to 7. So something like this we have to create. So simple thing, right? What we can do is we have to have a copy of every node, right? 7's copy we have to have. So we can create a hash map. We will have a hash map in which this key and value pair will be there. So key will be the original node, this 7, this is the original node, and value will be the its copied node which we have created. Fine. So here when I'm writing 7, it means we are storing not this 7 value, we are storing obviously the addresses, right? Addresses. For now, like for here, like explanation purpose, I'm writing 7, but that doesn't mean that 7 is stored. Address of the node is stored, right? Address of node, not the value of the node. Similarly, we'll be storing all nodes copies. So 13's copy will be stored in the hash map. Similarly, 11, 10 and 1 copies will be stored. 11, 10 and 1. Fine. Now it's very simple what we need to do. So first step was what? Create hash map. So how we created hash map? So first step was create hash map, where key is the, what is key? Key is the original node which is given in like this node which is given in the linked list. Original node, and value is the copy node which we created. So first step is what we'll do, we will traverse this linked list and we side by side will be creating a copy of this 7. So 7's copy will be created. This is a new node, and this new node, this 7 we will store in this key, and new nodes we will store in the value. So then we go to the next node, we create its copy, and 13 we store here and copy we store here. So then we go to next node. So similarly, like what we are doing, we are just going to the next nodes, right? This is the way we are doing. Now after this, what we have after this, what we can do, once we have created all the copies, right, then it's simple. What we just need to do is, let me erase this, then we just need to connect the nodes next and the random pointers. So what we need to do, second step is connect next and random pointers, next and random. That is, we will start from this 7. This 7's copy is here, 7. We will grab that, we will get that, and its next, 7's next is what? 13. So 13's copied we will get from the hash map, and that we will connect with this copied 7's next. Fine. So in this way we will be doing. Then we will go to 13, and 13's next is what? 11. So this 13's next should be the copy of this 11. So what is copy of 11? Copy of 11 is here, this one. So that we will store. Fine. Like this we will make the linked list. And random pointers, same thing. We are here, let's say we are at here 13. This 13's random pointer is what? 7. So this 13's random pointer will be this 7, right? So we need to get the address of this 7. So how we will get that? This 13's 7, this one. So this 7 we will connect with like this. So 13's random will be equal to 7, this 7. So similarly, this is the approach like using hash map. In this we are creating this hash map, which is extra data structure. We are storing the copy node of each node as value, so that we can get it whenever we want. Like for this 11, I want this 11's random pointer is at 1, right? So this 11 will be pointing to this one. So how we can get this one? This one is stored here. So we know we can get from 11's 1, this we can get. So from this key we can get the value, and then we will connect it with 11's random will be equal to 1. Fine. So this is one approach. This is one approach. Try to write code for this approach. We will see now the next approach, which is more efficient. So let me do one thing. Let me make this linked list again. The random pointers. Fine. So see, 7's random pointer is pointing to null. 13's random pointer is pointing to 7. 11's is to 1. Yeah, let me erase this. And then we have 10. So 10's random pointer is pointing to what? 2. 2 index node, which is 0, 1, 2, 11. So 10's is to 11 and 1 was at 0. So 1 is at second. So 1 is at 7. Fine. So this is the linked list. Now let's see the second approach. In second approach, we have to avoid, see earlier what we were doing. We were having a hash map in which we were storing the copy of that original node copy we were storing. So that we have to eliminate somehow. We have to store, see, we have to store the copy. We have to store the copy somewhere, but we should not use any extra data structure for that. Extra data structure we should avoid using. So in order to avoid using any extra data structure, what we will do is, see, it's a very good learning in this problem. So let's see, I have created a copy of the 7 node. This is the original node. I have created a copy of this 7. So this is a copy. Fine. Now what I will do now, I have to store, earlier what I was doing, I was storing this copy in a hash map with the original node, right? Original node is 7 and I was storing its copy. But now I have to avoid this hash map. So how we will do that? We will be, see what we will do. We will be storing the copy next to the original node. See, 7 is the original node. It's next. 7's next is 13, right? What I will do, I will make the copy node and I will attach it to 7's next. So this original 7's next will be pointing to the copy node. And then this copy will be pointing to 13. So what I have done, see guys, very important. What I have done, I have made a copy and I have inserted it here after the original node. After the original node. Fine. So see, next, what we will do, we have to create, now this 13 is there. We have to create this 13's copy. So that 13's copy we create and we attach it to the 13's next. And 13's next was 11. Now that gets attached to this copy 13, 11. Fine. Similarly, so see, yellow one is the original node. Yellow is the original. White one is the copied one. So 11's copy we will make and we will attach it with the 11. And 11's next was 10. Now it gets attached here. So then 10 is what? 10 is original. We have to create its copy and that we will attach after 10. And this one will connect after this 10. This is a copied node. And 1's copy we will make and we will attach it after this one, and then this null we will be here at 1's next. Something like this. So see guys, now we have avoided using the extra data structure. that is hash map, and we have stored the copied. This is the copy node. See, this is the copied node and this is the original node. So this way we have stored. Fine. I hope you understood this fact. Let's see the code also, how we have created a copy and how we have inserted it after the original node. So this is a function, right? This is a function. I am copying this code so that we can dry run it as well. Let's do it here. So see, this is the code, right? In the function, this problem, we are given this function and head of the linked list is given, and we have to return the head of the copied linked list. Fine. So what we are doing initially, we have taken this current variable. So current head of the linked list is given. So head is this one. Fine. Head is this 7. And what is given? We have taken current and we have taken a pointer variable current and it's storing the head, that is 7. And we have taken a next pointer also, which is currently we have not assigned it anything. Let's see how. Let's see. So we are now we are creating this linked list, right? That is, we are adding the copied node after the original node. So let's see how we will do that. This is the original node, right? This is the original node or original linked list. So see, first of all, what we have, current is not equal to null. So current is right now 7. What we will do, we'll make a copy of the current value. That is current node's copy we will make. So copy we are making. This copy we are making of this current node 7. So current is 7, right? Current is 7. So its copy we have created. This is a copy node. So current's next. That is 7. 7 is current, right? 7's next. 7's next we are connecting with copy. So see, this is copy node, gray one. Hence we have connected these. 7 is current. Its next is now the copied node. But see guys, once if we connect this current with the copy node, this 13 is lost, right? Because this 13 was connected to 7's next. That is current's next. Current's next was 13 initially. But now since we have added copy here, this 13 will be lost. So for that, we are storing this current's next first in the next variable here. That is, next will have 13. Fine. Now we can override it. So now 7's next will be the copied node. And copied node's next should be what? 7. This copied node should be connected to what? This 13, right? So copies next is connected to the next variable. Whatever is in this next. Next is 13. So this is connected, right? So see, we have created this part. We have created this part. And now, so current will be, now current should point to again 13, right? It should come to this 13. So 13, that is stored in next. So current will now become 13. Current is equal to next. So again what we will do? Again what we need to do is we need to make the copy of this 13 node and we have to connect it with this 11. Same thing. So same we will do again. So see, current is not equal to null. Yes, 13 is not equal to null. Next of current's next. 13's next is what? 13's next is 11. We will store that in next and we will make a copy of this 13 node. The copy is created. So that copy we will store in current's 13's next. This copy is stored and this copy's next was what? 11. That is next. Copy's next is 11. Similarly, we will go to current will go to next. Current will go to next. That is, current will become 11. So now current is here. So again 11's copy will be made and it will get connected. So in this way guys, in this way we will be creating this linked list. Fine. I hope you understood this part. Until this you understood. So this much we have done. This much we have done. So right now what after this while loop, once this while loop is completed, we will get this linked list. Fine. Now let's see how we will proceed further. Now what we have to do, see what we have to do, what is the second step? We have to now connect the random pointers. Fine, that is here 7, this is original node, right? So 7's random is connected with this null, and this 13's random is connected with 7. So something like this is there, right? This 11 is random is connected to 1. This is the copied one, sorry. 11 is connected with 1, and the 10's random is connected with 11. Something like this is there, and this 1 is connected with 7. Fine. So now these all random pointers are of original nodes. We have to create the random pointers for the copied nodes also, right? So 7, this is the copied node. This 7 is the copied node. So its random will be pointing to 7's like this will be pointing to null only. So this is null only. But for this 13, this original node's random was at 7. So this 13 will be random will be 7. This 7 copied 7. So that we will do now. So let's see through the code. Current we are again pointing to head. So current will now again be pointing to head. So head is what? Head is 7. Fine. And now let me copy this code. So this thing we are using this while loop, we are connecting the random pointers of the copied nodes. So see what we are doing. See this very carefully. So current is not null, 7 is not null. Current's random is not null. Also, so see, this 7 random is null, right? So nothing we should do for that. So if this is not, so this if it will not go this inside this while loop, if block, and we will move this current to current's next. Why we are skipping two steps? Why we are taking 2 steps? Because this is a copied node, right? For copied node which should not go. So current is initially here. Now current will go to current's next. That is here 13. Now current is 13. Now let's see here what we have. See, current is not null, 13 is not null, and current's random is not null. 13's random is what? 13's random is 7. Fine. So now what we will see, so what we will do now? We have to connect this copied 7. This is a copy of copy of 13, right? So current, where is copy of 13? It is in current's next. This 13 is the original node and its copy is in current's next. That is here, 13's next. This is the copy, and we have to set its random pointer. And what will be the value of its random? It will be this 13's random, which is this 7, that is current's random, and this 7's next, which is the copied 7. So this will be the code we will write. So to connect the this copy 13's random, it will be the original node's random 7, and its copy is where? To its next, right? So it's next. So in this way we will connect. And once we have connected, now we will have to go to 13's, this copied node 13's we have connected. Now we have to connect for the copy 11. So from here, from this 13, we will go to the 11, this copied original 11 node. That is current is equal to current's next. So just try run once, you will better understand how it's working. I hope you understood this. So once we have done it, right, we have connected the copied nodes. We have connected the random pointers of the copied nodes, right? Now what we need to do? Third step. This is the third step. In the third step, what we are doing is, so something like it's real messy. Let me just erase this. So third step, first step what we done? We have created the copied nodes and we have inserted them after the original node. That was the first step. Second step was we attach the random pointers of the copied nodes. Third step is now we have to separate the original linked list and the copied linked list. That is, original linked list is the yellow nodes 7, fine, or original linked list is 7, 13, 11, 10 and 1, and the copied linked list is the gray white one 7, 13, 11, 10 and 1. Fine, so this will be the new head which we will return. So this code, right, this code from here to here is the code to get the copied node from this linked list, copied linked list from this linked list. So that, let's see how we are doing. So I will give an overview of that. This code you can try run once, you will understand how it's working. So see, initially what we are doing is current is 7 at the head, and we are taking two pointers, right? One is the dummy, one is the copy, and other is the copy tail. So copy and copy tail. Copy tail, we are initially we have created a dummy node. So I which is like it's a dummy node. So I have insert copy tail containing dummy node is pointing to dummy node. Fine. So let's say it's dummy. Now what we will do is, see, we will be, we have to segregate, right? So this 7, this yellow 7 should be now, its next should be connected to the original, like this 13, and this 7 which is the gray one, its next should be connected to the copied 13. Fine, just we need to separate now these. So how we will do that? First we will store the next currents next, that is if currently we are at 7, right? I will show for 7, rest of you can like dry run. So see, currently our head is at 7, right? Current is at 7. So in the next variable I am storing currents next, that is this 30. Fine, I stored this. Now what I should do is, this 7 I have to pick up currents next in copy. So copy variable I am writing currents next. Current is 7, 7's next is this gray 7, white 7, right? After that, copy tails next should be this copy, that is this dummy. So somewhere dummy node is there, and this here we have copy tail pointer pointing to it. This copy tails next should be connected to this one, this 7. So that is copy tails. What we are doing, copy tails next should be equal to the copy, which is 7. So we are now making this 7, we are making this copied linked list here. So 7 will be connected here, and now copy tail obviously will go here, so that whenever the next node comes, it get connected at the end. Copy tail we will update. So copy tail will be equal to copy 7. Copy tail is now at 7. Fine. So here we are creating this copy linked list, and after that now this 7, original 7 which is at current, its next should be what, this 13, right? So that is showed here in next, that is currents next should be next, restoring the original linked list. And then we have to just go to this 13 so that we can do the same thing for the rest of the linked list. So current will move to the next will now become current. So I hope you understood this thing. At last we have to store the head of the copied linked list, which is dummies next. Fine, so we will return dummies next. I hope you understood the problem. Let me know in the comments if you have any doubt. Time complexity is linear. We are going to nodes, like it's in linear only. So O of n will be the time, and space is constant. So yeah, let me know in the comments if you have any doubt. Dry run once this algorithm, it will be more clear. And if you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video.